we're going to look at our number 5 again, but we're going to change the question a little bit. The question was, how long will the rocket remain in the air? I changed the question to how long will it take for the rocket to reach a height of 20 feet, just so we can kind of get an idea of how this kind of changes the solving process. So before, we set h of t equal to 0 because it wanted to know how long it would remain in the air, so when would it hit the ground, which is a height of 0. In this scenario, they want our height to be 20 feet. So instead of plugging in a 0, I'm going to plug in a 20. Everything else is going to kind of remain the same. My velocity is still 100, and my initial height is still 5. I'm still going to set up my quadratic formula as I would have liked. However, before I can do my quadratic formula, I need to make it equal to 0. This is equal to 20, so I have to scoot over that 20. When you do 5 minus 20, you get negative 15. Now that my quadratic equation is equal to 0, I can go ahead and use the quadratic formula. So I'm going to set it up with my negative b plus or minus my b squared minus 4 a and c all over 2a. Now I recommend, I'm not going to go through all the steps, I recommend you pause the video, try to solve it, and we'll compare answers at the end. Alright, I simplified my quadratic formula, and because it's real world, I was able to go into decimals, and the two answers I got were 0.1538 and 6.096. Now I'm going to go back and reread my question to make sure I can pick out my correct answer. The question was, how long will it take for the rocket to reach a height of 20 feet? From what it looks like it's going to take 0.15 seconds to go up to 20 feet. It's going to reach its maximum, then it's going to come back down and start falling, and at 6.09 seconds, or you can round to 6.1, it's going to come back down and be at 20 feet. Because you know a parabola goes up and then comes down, it looks like right here it's going to be at 20 feet, and right here it's going to be 20 feet. So I need both of those answers. So far I've been only using one. So I want to caution you, you want to go back, reread the question, and then re-look at your answers. Make sure they make sense. Both of these are positive. At both of these heights, that toy rocket is going to be 20 feet above the ground. So I need to make sure I keep it. Now, let's look at another problem. 6 and 7 are two more symbolic, so we're going to skip them. Now, if you look at number 8, we're going to skip it because we just did it. All right. Now, number 9 is a little bit different because this is no longer about a projectile getting thrown up into the air. It's not about garbage or toy rockets. This is just a different quadratic equation, and this deals with distance. So you got the formula D, and they give you the equation. It models the runway length required to land a small plane, where D is the length of the runway, S is the landing speed, so they're kind of telling me what the variables are, of the airplane in feet per second. A pilot knows that the runway is 4,000 feet long, so runway is 4,000. I'm going to need that information to go with my runway variable. And they want to know the maximum safe landing speed, so they're asking me for the landing speed. That's what they don't know. That's my variable. So I need to set this for my D. That's my 4,000 because that's what they want the runway length to be. They want it to be 4,000. So it's not going to be 0. It's going to be 4,000. And then S is my variable. So again, just like the last problem, can't use the quadratic formula yet because it's not equal to 0. In order to make it equal to 0, I have to subtract that 4,000 over. So let me subtract that 4,000 over. Then I have it equal to 0. And I can go about solving for my quadratic equation, 39. Alright, and I'm going to use the letter S. Again, you can switch it to X if you are more comfortable. It really doesn't matter at this point. So I'm going to set up my negative b, which in this case is a negative 2, so it's going to switch to be a positive 2. I'm going to simplify my discriminant just so I can kind of maintain consistency on how I've been doing these. And my discriminant works out to be 1,600. So this is 2 plus or minus 1,600 all over, I'm going to simplify this to be 0.2. And 1,600, it has a nice square root of 40. I can go into decimals pretty easily here. My two answers, when I go through and simplify them in the calculator, I get 210 for the first one, and for the second one, I get negative 190. Now I'm going to go back and find my question. What is the maximum safe landing speed she can have? So I've got 210 and 190. Well, I probably don't want to have a negative landing speed, so I'm going to say 210 feet per second. That seems to be quite an answer. It says round to the nearest feet per second, so we've got 210. That works for that problem. Now the previous 4 or so examples that we've done, they all have something very similar. They give you the equation, you have to plug in the information, and then you just use the quadratic formula to solve. This next equation is the last type of quadratic equation you should see that is real world, and it's very different from the others. We're going to draw a picture like we did on the other ones, but there's going to be a bit more steps and a bit more simplifying. So you got Jeff having a rectangular garden that has a length that is 1 foot longer than twice the width. So in this case, I'm literally just talking about a rectangle, so I'm going to draw myself a rectangle. And it says the length is 1 foot longer than twice the width. To me, length is usually the longer side, so I'm going to do length. And it says 1 foot longer, so that's a positive 1. 1 foot longer than twice the width, so that's 2w. So my length is 1 plus 2w. I don't really need that plus in front of the 1. I just want to make sure I know it's a positive 1. Then they're telling me the area of the garden is 30 feet. Well, it's a rectangle, so if I remember from geometry, the way I find the area of a rectangle is length times width, and they're telling me the area is 30 feet. I'm going to add that to my picture. And then they want to know what the length of garden is. Well, I've got my length labeled. This must be the width. I don't have that labeled, and I've got my 30 feet. So I've got my area for my length. Because I have an expression for my length, that's what I'm going to write down. I'm going to write down the 1 plus 2w. And that whole thing is my length. So I want to make sure I put parentheses around it so I know that whole expression is the length. And I need to multiply that by the width. So before I can keep going, I have to simplify this. You notice that it's not equal to 0, and you've got some parentheses. If you think back to Algebra 1 or earlier in Algebra 2, your gut when you see parentheses, you want to distribute that w. So you're going to distribute that w to both pieces. That's why it's really important you put parentheses. So you've got w times 1, which is w, and you got 2w times w, which is 2w squared. Now it's looking a bit more quadratic. I'm a bit more comfortable. Those parentheses are very important because if you don't put them, you won't know that's your entire length, and you won't know to distribute. I'm going to switch my 30 over. I'm going to flip it to the other side. So then I end up with 0 equaling w plus 2w squared minus 30. Now this is all wonky. It's in a different order, so I'm going to rearrange it just so it's a little bit more in my comfort zone. I'm going to put the 2w squared in front. The w can go in the middle, and the negative 30 can go in the end right where it's at. So this problem has a bit more setup, but right now it's quadratic, and it should be within your comfort zone. I can now just go through. Again, I'm going to use w. You can switch it to x, but I'm going to use w, and I'm going to set up my quadratic formula as usual. So w and my negative b plus or minus square root of 1 squared minus 4 times 2 times negative 30 all over 2 times 2. Now, as you go through, I'm going to simplify my discriminant just for good practice. And I get 241. So I know there are going to be 2 real solutions. On the bottom I get 4. Now when I go through and plug this in my calculator, I'm going to get 2 answers. And the answers I get are 3.8 3.63 and negative 4.13. Those are the two answers. Now I'm going to go back and reread my question as I have for every single problem, and I'm going to make sure I answer it. So they want to know the length. What was the length of the garden? Well, I know I can't have the negative because you can't have a negative length, so I'm going to consider the positive 3.63. However, if you notice the question says length, the letter we solved for was W, and W stands for the width. So right now I have solved for my width, I have not solved for my length. What I have to do is I have to take that 3.63 and go back to the expression I wrote at the beginning, where my length was equal to 1 plus 2W. And I need to plug in my width. So in your calculator, if you simplify 1 plus 2 times 3.63, you should get L equal to 8.26, and that is the length, and this is in feet because I went back and looked at my problem, I saw it was in feet. That would be in feet. So you have to be very careful because they might ask you for the length or they might ask you for the width. It's going to depend on if it's the end of course or if it's the ACT. Another way you can go through and do that is once you have your width, you can go through. Some people prefer to take their width because they go back to their original formula of 30 equals length times width. They can solve for their length that way. And you divide both sides by 3.63. You get the same answer as your length being 8.26. So either method works. Just make sure you're careful when you go back and reread the problem. So in summary, we've worked on 5 or 6 word problems or real-world applications. Real-world applications always have to go to decimals, and you always want to reread the question before you select your answer. You may need one of the answers, you may need both of the answers, or you may have to go back and do some extra simplifying and some extra work as we have in this last problem.